Hello everyone! We will just wait 1 minute before we start to make sure everyone is on board. Thank you. So, hello everyone. SBG Systems is pleased to welcome you today to a new webinar entitled Introducing Pulse-20 and Pulse-80, the right IMU for every application. I am Noémie Remilly, Event Manager at SBG Systems. Before we start, just a little focus on logistics. You have the possibility to ask your question using the private chat box located on the right corner of your screen. We will try to provide live answers during this session. And you can also hide this box for a better display on your screen. I will now welcome on the stage my colleague, Johan Plenet and Émeric Lemercier. Hello. So Johan Plenet, Head of Product Management, will present you the full Pulse IMU product line, including the new Pulse-20 and Pulse-80. And then Émeric Lemercier, Test and Qualification Team Leader at SBG, will focus on the test and qualification process used at SBG Systems. So, Johan, I will now give you the mic so you can introduce quickly the company.
Thank you, Noémie. Indeed, I'll start with a brief introduction of SBG Systems. Most of you are probably very familiar with SBG Systems, so I will be very rapid. So SBG is a company created 18 years ago in 2007. We focus ourselves on providing solutions for orientation, stabilization, and navigation. So mostly sensors, IMUs, INS, etc. Since inception, we have deployed more than 40,000 sensors in the field in more than 1,000 customers all around the world. We have more than 50 countries, much more than 50 countries actually, if we look at the full list. Our products can be summarized in 3 categories. The first are the one we are going to focus on today, which are the IMU, the raw motion sensors. That provide acceleration and rotation measurement. But we also have systems, inertial navigation systems and AHRS, which are designed around our IMUs, and on top of which we integrate a built-in GNSS receiver, our algorithms, etc., to be able to provide full orientation and position measurement. We also have a wide range of software solutions. First, SDK, software development kit, that we're going to discuss a bit later in the presentation when we cover the IMUs. But we also have a wide range of other solutions, such as drivers for Pixhawk or RD Pilot, and even a full-fledged post-processing kinematic solution with Inertial in its desktop or cloud variant. But today we are really going to focus on the IMU and on the IMU product. And very importantly, also on top of our products, we have free remote support that's available for all our customers. So if you have a question, feel free to contact us, to reach to our support. It's a dedicated team of field engineers who are here to help you with any of your questions, whether it's about the product, the integration, etc. And we also have, of course, the capacity to intervene on site to support you more in depth if needed. Now let's move on to the introduction of the different IMU that we have. As you can see, we have 3 IMUs at SBG. I'm going to start not in order of performance, but I'm going to comment first on the Pulse-40, because this is probably the IMU you're the most familiar with. So the Pulse-40 is a miniature tactical grade OEM IMU. Why is it the first one I'm presenting? Because it's the one that we've introduced the first. It was launched in 2022. We've had a lot of field feedback, and it's been a very successful launch. that encouraged us to release now in 2025 the Pulse-20 and the Pulse-80. So the Pulse-20 is a sub-miniature industrial grade IMU that has bias instability of around 7 degrees per hour. On top of the 3-axis accelerometer and 3-axis magnetometer, it also offers a magnetometer, and it's also available in serial connectivity with RS-232 and RS-422. And then we also have released earlier this year the Pulse-80. The Pulse-80 is much higher grade. It's really high tactical grade and close to navigation grade IMU with the bias instability at 0.1 degree per hour. And the Pulse-80 comes in 2 flavors, the OEM version and the box version. The OEM is perfect for integrators where size, weight is a constraint, who already are doing a mechanical and electrical integration. The box version is slightly bigger because we're putting the enclosure around, plus interface board for RS-422. But otherwise, they are exactly the same in terms of performance, etc. So it's really a question of depending on what is your integration and which one fits the best for your integration. With this, as you can see, we have a wide range of products of IMUs now that cover different performance level. On all these IMUs, we make sure that we have the same set of characteristics so that you can, if you do any development or any integration with one, it will scale with any of our other IMUs. So I'm going to present the common characteristics of our IMUs. And first, and maybe very importantly, or most importantly, I don't know, that all our IMUs are manufactured in France. So in our head office in Carrière-sur-Seine in the Paris suburbs. We only use components that comes from European or North American manufacturers. But despite that, all our IMUs are ITAR-free and even EAR-free. Even although we integrate North American components, we are below the thresholds that would trigger the EAR contagion, so the de minimis rule. Something very important for the IMUs is the calibration. When you're buying any IMU at SBG Systems, it's been individually calibrated. This calibration is what really allows us to guarantee the performance level of all our IMUs, because during this calibration, we do a full compensation of the various errors of the IMU. And this is also, let's say, the final test to make sure that the IMU meets the performance level that we define. But I'm not going to go into a lot of depth on this topic for now, because Emric is going to cover this with a lot more details in the coming slides. Another common feature of our IMUs is the output data rate. So all our IMUs can support an output data rate up to 2 kilohertz. You can, of course, configure it to be lower if needed, but all of them can go up to 2 kilohertz, which is really the sweet spot for integrators who want to do control or stabilization with our IMUs with a very high frequency, low latency solution, so that they have the lowest motion to output frequency. You can also see on the lower part of the slide the sampling loop and the filtering that we applied. My target is not during this webinar to have a long presentation of the sampling loop and the filtering, but this gives you an overview of the FEAR, all the application of the calibration, the computation of the CBIT, etc. And if you need more details, you can either see our documentation that goes into a lot more depth about the filtering, or contact us for more details. Another important feature of the IMUs is that all our Pulse IMU offer 3 different modes of clock. The first one is the internal clock, where we use the internal oscillator of the Pulse IMU, and this internal clock drives the sampling loop at 2 kilohertz. But we can also use an external clock with 2 different modes. The external clock direct mode, in which case you need to input us a 2 kilohertz clean clock, and this 2 kHz clock will drive directly our sampling loop, and then will output at the specified ODR based on the configuration. The second external clock mode is the external scale clock, where if you provide us a clock that's not at 2 kHz but at any multiple of 500 microseconds, then we do the scaling internally, drive the sampling loop, and then output at the ODR. This gives you a lot of flexibility, whether you want to do an integration where you use the Pulse IMU as the master clock, and you can use the internal clock. If you have a clean 2 kHz oscillator, you can use that directly as a direct external clock. Or in the case, for example, where you have a GNSS that can output a PPS, then you can use an external scale clock to drive the IMU clock. That's some of the options. There are multiple other ways to use these external clocks, but that gives you, let's say, a high-level overview. Maybe now that we've presented the clocks, you maybe wonder how you can configure them on the Pulse IMU. And before I go into the detail of the configuration API, first thing I want to mention is that we have a unified software ICD for all our IMUs. So all our IMUs use exactly the same API. First, they all have the same configuration API, and we have a REST-based configuration API that lets you very easily configure all the different parameters of the IMU. So you can see on the screen here an example where we're configuring the ODR, but you can also configure the clock mode, the synchronization modes, the data messages you want to send, etc. All of this can be configured with the same API, and this API is designed to be very easy to use, very easy to read, and very easy to maintain. On top of the configuration API, we of course have a communication API, so all the IMUs output messages using a proprietary binary format called SBG ICOM. And we have the same SBG ICOM API for all our sensors, so all our IMUs, but also our INS and AHRS also use the same API. This API also is very, very extensively documented, and you can see a screenshot on the right of the online documentation freely available of the SBG ICOM API. And on top of this documentation, we provide a C library that you can directly integrate into your software for easy parsing of all our messages. On top of our API, for when you get started with our IMUs, we provide some software tools as part of the software development kit. The first one is SBG Center. SBG Center is a GUI software that you can use to do some acquisitions, but also and mostly to visualize the data from the IMU. So you can use it to visualize in real time the data that comes from the IMU, or even to visualize recorded acquisitions and analyze them afterwards with some easy-to-use graphs, etc. And all the data that's output from the IMU can be monitored directly in SBG Center. On top of SBG Center, we have SBG Basic Logger, which is mostly used for acquisitions. It's a very simple tool, very simple command line interface tool that you can use to trigger some data acquisitions and or to convert acquisitions to ASCII, so that you can have some let's say data in a format that's easier for you to understand or easier to parse with other tools. So both these tools are tools that we use on a daily basis. Internally, both our engineers and our support team use SBG Center and SBG Basic Logger on a daily basis. And these are really the tools that we would recommend for you when you get started with our IMUs, so that if you have any questions, they'll be able to support you because they use the tools daily. Now I'm moving on to a very interesting new features that we've introduced into our IMUs recently, the vibration monitoring feature. Before I introduce before I present the feature, why have we introduced that in our IMUs? As you might know, and Emric will explain that later, our IMUs are based on MEMS sensor, and these MEMS sensor use vibrating parts. And when you integrate, while you put an IMU in an environment where there is vibrations, these vibrations can cause perturbations to the IMU. This is an issue. This is something that some of our integrators have had issues in the last few years. So what we've decided is to build in directly inside the IMU a vibration monitoring feature that comes in two different aspects. The first one is we provide a full vibration spectrum. So we give you a full spectrum of vibration during a Fourier transform with a 0.25 second window. We give you a full spectrum up to 2 kilohertz, and you can see below an example of the vibration that we can measure during a sine sweep from 20 hertz to 2000 hertz with an increase of frequency of 1 octave per minute. And you can see very clearly on the graph the frequency increase over time as we are injecting higher and higher vibration frequencies in the IMU. So this is a very powerful tool to be able to analyze very finely the vibration that you inject to the IMU. And this is something that you can also share with our support team so that they can help you with your integration. But it means it's also something that's a little bit complex to use. So we've decided to also, as part of the same vibration monitoring feature, put something easier to read, easier to understand, which is the synthetic vibration report, where on top of providing the full spectrum that you saw before, we provide the Fourier value aggregated for 4 evenly spaced frequency bands, and for each frequency band, we provide the GRMS, the peak frequency, and the magnitude of the peak frequency. This is something that's easy to read, that you get epoch per epoch with a 0.25 second resolution, as I mentioned before, and that can let you very easily see the level of vibration that is injected at a given epoch. You can see on the screenshot the result from the same sine sweep, where you can see the 4 frequency bands and the measurement of the vibration injected at the 4 frequency bands. And also you can see on the bottom right the same result visualized in SBG Center, and where you can see the 4 frequency bands and all the measurements I've mentioned before. And maybe this also gives you, if you pay attention to the details, a bit of sneak peek of what is going to come soon. As you can see, I mentioned that it goes up to 2000 hertz, but here you can see on this screenshot that the measurement doesn't stop at 2000 hertz. We are working on increasing the bandwidth of the vibration measurement to go up to 8 kilohertz, and you can already see the result here in this screenshot as we are going higher. So this is spoilers for some feature that is going to come soon in some of our IMUs. Now, moving on to another important feature, and as I mentioned, in the Pulse-20, we have a built-in magnetometer on top of the accelerometer and gyroscopes. On top of this magnetometer and the raw magnetometer data, we provide a tool that lets you do the calibration of this magnetometer. So first, we do the magnetic calibration of the magnetic environment. So we calibrate for the magnetic perturbation caused by the integration or the vehicle itself. So the soft and hard ion calibration. But on top of that, our magnetic calibration tool provides also what we call bore-sight alignment, which is the alignment of the IMU and the magnetometer frame, and which is much more complicated to do than the magnetic calibration itself. So with this calibration tool, you have a solution to very rapidly start an integration of the Pulse-20 with the IMU data and the magnetometer data. And that covers the key features that we wanted to highlight today. We're going to move on to the production and qualification of the IMUs. And maybe as an introduction, for all of our IMUs, we need to make sure that we provide a full data sheet with all the specification. When we do this data sheet, it's very important for us at SBG that the data sheet is actually realistic and representative of what you're going to get when you buy any of our IMUs. So we have some criteria that we use when we make this data sheet, and we need to make sure that it's realistic in the sense that it's achievable under the expected operating conditions. It needs to be representative, so we need to make sure that we take into account the fact that there is some variation between individual IMUs. It also needs to be consistent over time. So here it's not really a question about the individual tests that we do, but making sure that across the time we continue evaluating and auditing our manufacturing tools to make sure that we still meet the same performance requirements that we had at the start. And then finally, it needs to be stable over time. So when we specify a data sheet, we need to make sure that everything that's specified in the data sheet is going to take into account the fact that the performance evolves and degrades over time with the aging. So how do we achieve all that? With a lot of testing, qualification, aging, the test during manufacturing, etc. And this is what Emric is going to present you. So I'm leaving you with Emric now.
Thank you, Johan. So as said, Johan, I will go a bit deeper on IMUs. So when we talk about IMUs, for us, we talk about 3-axis gyroscope, 3-axis accelerometers, and 3-axis magnetometers. We also have temperature sensor and vibration measurements, but mainly we'll focus on 3-axis gyroscope and 3-axis accelerometer for this site. So if we look at the IMU developed at SBG, we will have industrial grade like the Pulse-20. We will have tactical grade like the Pulse-40 and the high-end tactical grade Pulse-80. So when we talk about industrial grade, it means that you can use the raw data from the gyroscope and accelerometers, which mean rate, angle, or acceleration. And when we talk about tactical grade, we talk about to be able to use the integration of the data. So we talk about speed and angle and have reliable data for 1 minute to several minutes if you have in the high-end tactical grades. So SBG is known to integrate many sensors. So mainly I will take the example of a coiled gyroscope. So coiled gyroscope is just a single mass. So we have the proof mass. And this proof mass will be excited on the x-axis, which is named the driving mode. And if we have a rotation in outside of the plane, what we saw, we will see a rotation of the mass, which go to the y direction, and this will be the sense mode. So why SBG is taking MEMS as sensors is mainly because it's small, you can mount it on a PCB, low power and very robust, so reliable. So as soon as you calibrate it, you almost doesn't need to recalibrate it at all in the lifetime. But as I said earlier, we have excitation, so we need to pay attention to vibration, because otherwise we can inject some kind of perturbation regarding vibration or acoustics. So that's why we need extensive qualification to be able to know where are the point of susceptibility that we need to tackle in an integration. If we now will look a bit more on the market, you can see that there is a large range of variety of IMUs. So you have AOM IMUs or ruggedized IMU. SBG system is positioned on both sides. We have cheap or integrated sensor. SBG is only on the integrated sensor part at this time. And regarding calibration, you can have no calibration or extended calibration. So SBG calibrated every IMU, so with extended calibration to have really high reliable IMUs. And we also have full qualification of IMU to be able to specify good data sheets. And if we look at the price, we can have some cheap of few dollars or even high system with, which can cost thousands of dollars. We are in the middle of this kind of range. So now what we want to emphasize is our process. So as I say, we manufacture internally OM or ruggedized version of IMUs. We developed a full automated production of our IMUs with SBG calibration tool. And what we do after production is we have extensive qualification on precisely production files to be able to tackle most of the performances of our IMUs and also doing accelerated aging and long-term performance evaluation. So I propose you to go to all the phases to know a bit more what we are doing in every phase. So now if we start by IMU production, as I said earlier, we have a software. This is SBG calibration tool. This software allows us to flash and identify the product. So all our projects are connected with our ERP to have good traceability of our sensors. Then we are able to do calibration of our sensors. We are able to calibrate the model and have all the traceability on our model. We are able then to validate the model and then do the final acceptance test to be able to send to the client the best performance IMU that we have. Now, if we look at what we talk about calibration for sensors, the main idea is to determine and compensate the sensor errors. So to do that, we need proof. So this is the rate table, which simulates rotation and position during thermal environments. And then what we have to do is to compare the sensor output to the stimulus that we have made with the rate table. So we have mainly 4 errors that we need to address when calibrating. The first error that I talked on the left part and the high part of the picture is the scale factor. And so you will need to have the blue curve from the sensor close to the rate table, which is the green curve, and to make them match with the factor that you have to add on your system. Then the second error is the offset bias. So you will need to be able to address the offset bias that we have in every temperature. Then the third error is the nonlinearity. So we have a bit more complexity to address the calibration of the system in temperature and in every situation with the rate table. And then the last parameter is the noise. And what we need to be able to do is to have mechanical structure which doesn't degrade the noise of the sensor, and obviously acquisition that doesn't degrade also the sensor. So mainly we want to be sure that our integration is good and quite aligned with the sensor datasheets. Then when we have our model, we will do the calibration. So here I put an example of the gyroscope and accelerometer sweep bias residual. So as you can see, it go for 80 degrees C to minus 40 degrees C. And then we have some points of compensation where we will evaluate the bias variation, the linearity and scale factor of the sensor, and also the alignment between the sensor and the mechanical frame. So this will be reported in the calibration report, and then we have all the residual error for every sensor, and the status need to be passed for everything. And we also check the thermal hysteresis during this phase. If everything is okay, we will be able to store the IMUs. So the IMU will be stored from 1 week to 1 month. And the main idea between the storage is to be sure that the calibration that we did earlier is still stable, so we don't see any drift, and we are within the performances after 1 month. So this is done with a second independent validation. We start from minus 10 degrees C, then 20 degrees C, and 60 degrees C. And we have power on of the IMU at all these 3 points, and then we evaluate the bias, the linearity, and also the alignment of our system. So this consists of the first part for the final acceptance test. And then at the end, we also are doing functional analysis of a sensor at ambient temperature. So we look at the power consumption, the sync out of the signal, the status that we have on the sensor, and then we also check that the temperature and the sensor performance for accelerometer and gyro are within our specification. If everything is aligned, taking into account the calibration, the validation, and the functional test, then we will upload the firmware for the customer, and then we upload also the validation directly to my SBG, so the client will be able to see on SBG Cloud the report of the validation of the sensors. So this wrap up what we do for production of a system of IMUs. And then what we had full automated performance monitoring. So with this software, we are able to track every calibration and validation of every IMUs that went to our 2-axis rate table. And we are able to do analysis on some time on some date, and just to do a 3-year evaluation on some parameters in time on temperature, and then just be able to know if there is any drift on our production or if there is any sensor issue that we have to address in production. So this allows us to be able to address real data sheet, because we will see over time how our system as fresh test validation behave, and be really comfort to have the best performances sent to the clients after production. But this is not enough. So what we have to do when we launch a new IMU, we have to use a qualification process. So we did our own internal qualification process. So this starts with an aging of 1 month with IMUs that we take from the pre-series. So we can be up to 5 IMUs that we take for our qualification. Then we have 1 month aging, and then we do the first validation to have the first evaluation of the IMUs before the functional qualification, and then we start the qualification. For the qualification, we are using the norm MIL STD 810H. So this is the norm that allows us to have a good evaluation of our IMU performance on their different environments. So we are looking for thermal, vibration, and shocks. So to do this, we use 2-axis rate table, we use our internal shaker, or even climatic chamber to simulate thermal environments. I will emphasize some of the tests that we do in this functional qualification. The first, we do startup at high and low temperature to evaluate the capacity of our IMUs to start at 85 degrees C or minus 40 degrees C and to behave normally. Then we also evaluate what will be the performances of our system in vibration. So we want to characterize the error of a sensor with a vibration from 1 GRMS to 10 GRMS. And then we also evaluate if there is any resonance frequency on our IMU during sine sweep vibration from 20 Hz to 5000 Hz at 10 G. So to be sure that we have the best performances from our MEMS according to the vibration. Then to be able to evaluate a bit more the performance and the vibration, we do sine dwell, taking 100 Hz step and 30-second dwell evaluation. And we also integrate it if we know any resonance into this dwell as well to evaluate best the performances. Then we also look at the shocks. For the shock, we have 2 types of tests. One test, the half sine, which is 30 G with duration of 11 milliseconds and 10 shocks to evaluate performance before and after shocks, and even under shocks. And the other one is the high frequency shock, where we use a board just to inject high frequency and to see if there is any perturbation on the output of the IMU data. As an example to emphasize the functional qualification, I put here the accelerometer random vibration of one of IMUs at 2 kHz. So we have 5 PSD level from 1 GRMS to 10 GRMS on the Z-axis. And on the left part, you will have the MIL STD definition procedure. And then we did it with 5-minute exposure at each PSD level. And so what you see on the right side is just that you will have the first figure, which shows the bias of the accelerometers, which is shifting as we increase the PSD level. And so at the right side, you will have the VLC and the VRR, which is the error that you will have according to vibration. And then we have a linear compensation of 0.016 milli-G per GRMS square. So that's the first evaluation that we do. Then when we are happy with the functional qualification, we proceed to accelerated aging. Accelerated aging is quite difficult, as this part tend to just stress the project, but we can evaluate if it's 1 year or even more aging. But the main part is just to be sure that we have a system mechanically reliable and also good performance of our IMUs. So we still use 2-axis rate table, shaker, and also climatic room. So what we do first is, according to the MIL STD, is 100 turn on and off on the IMU. Then we do 50 hours pour on of the IMUs with the acquisition. And then what we do is just pour out of the IMUs and just do hot storage for 10 days at 85 degrees C and cold storage at 3 days at minus 50 degrees C. So this is for the thermal part, and then for vibration, we are a bit higher than the nil STD, as we do 15 GRMS on each axis for 1 hour on 1 hour, and for the shock, half sine 90 G duration 11 milliseconds, 10 times, and the IMU power off. So this ensures that we are able to see how our system will evolve in time. So at the end of the aging, we also want to be able to know what are the performances of our system at the end. So we also had the same functional tests at the random vibration and the half-sine shock, just to be sure that the parameters are behaving well and the IMUs are still within their first evaluation. We also had extended evaluation performance on operating performance like temperature, so temperature range to evaluate bias, linearity, and noise. And we also had acoustic characterization or nonlinearity evaluation, which consists for the nonlinearity to have 40G evaluation on accelero and gyro to see how it evolves in harsh condition. And then we also have acoustic characterization. If we look at acoustic characterization, we are going to another lab and then we put some of our IMUs and we are doing evaluation in a reverberant chamber. And what we do is 65 2/3 octave band test from 40 Hz to 20 kHz. And we do 1 minute acoustic exposure at 120 dB per sound per pressure level. And so with this, we are able to evaluate if we have any bias induced by noise or induced by acoustic, or even if we have noise induced by acoustic at some kind of frequency. Then when we finish all the tests that we want, we go to the long-term storage. So in this part, we just want to track the performance evolution in time. So we use the classical 2-axis rate table that we use in production and doing validation process with the 3 temperature measure points. So the sequence can be from each month, each 2 months, each half a year, or each year. And this will depend on the drift that we can observe on the IMU, which we say if we want to have a close surveillance of the data each month, or if we are okay with the data and go each year evaluation. So here is just an example of a performance evaluation. So this is 4 IMUs. It starts in January 2022, and it consists of 16 measurements with X, Y, Z mixed in 3 temperature points. And so what we saw at the beginning is we have a dispersion at the beginning. So it was when we do the functional qualification and the aging, and then we do the storage, and we see that the tendency tends to be really constant during time. So we are now each year evaluating the performances, and the last evaluation was last summer. So now that we saw the extensive tests that we do for IMUs, I will let, for IMUs to have a good datasheet, I will let Johan explain how we can switch from the lab test, because we only do lab tests, to have a real experience of our IMUs in the field directly for which application you will need.
Thank you, Henrik. Before I continue on which IMU for which application, just want to mention that if you have any question about our qualification, or if you want us to present you some more details of our results, the results that presented what Henrik presented, but you want to see it in more details, feel free to reach out to us and we can share some details with you offline. So now maybe to move on to which IMU we recommend for which application, and start with the Pulse-20. So the Pulse-20 is a really miniature industrial grade IMU with a 3 by 2 centimeters size and 10 grams weight. Makes it extremely compact and fit in every integration. This miniature size makes it very suitable for all applications where size and weight is a big constraint. But on top of that, it has very solid performance with the inherent bias instability of the gyro at 7 degrees per hour, or long-term bias repeatability at 750 degrees per hour. But it's also an IMU where we have a lot of field feedback, because it's the IMU that we've been using in our Ellipse INS and IHRS for over 10 years. So we're very familiar with how they behave in the field, and they're very resilient, very robust to vibration, to shocks, etc. And we put them to test in very harsh conditions. On top of that, the built-in magnetic compass can be very useful for some applications. Based on that, it can be used for a wide range of applications, but there are a few that we think it's very well suitable for. Everything that's about stabilization and control, so EO systems, short-range missile homing, the IMU small size, robustness, and good performance is really at its place. For navigation, this is it's not an IMU that will say that it's best for long dead reckoning application. When you lose GNSS or when you have no reference for a long time, the industrial grade performance level means that the position accuracy is going to drift over time quite rapidly. So that means that we don't recommend it for long dead reckoning, but for subsea orientation, just the orientation using the magnetometer and the good accelerometers and very good gyroscopes is a very suitable application. Or for application where you think you're going to have GNSS for the majority of the mission. And one application where this is something that we've seen is the IMU is very well suited is interceptor UAV that needs to navigate for short time, to reach for short time without GNSS. Then if we move on to the Pulse-40, the Pulse-40 is barely any bigger than the Pulse-20, but it is a lot more performance. We go down to 0.8 degree per hour in-run bias instability and 250 degree per hour bias repeatability for a small increase in size. On top of that, it has an extended range. It goes up to 2000 degree per second measurement on the gyro, along with the 40G that we have on the accelerometer for all our IMUs. But also, and I think I can't emphasize enough, it has a very, very low noise, especially for this performance class, and a very good in-run bias. This makes it very suitable for any stabilization and control application. I'm not going to name all of them because the ones where it won't be sufficient are not very common. But on top of that, it is a very good IMU for navigation. Assuming that you're going to get some GNSS at some point during the mission and you want to bridge in the gap, so doing some medium to long-term dead reckoning, 10, 15 minutes, as long as you want it can be, the Pulse-40 is very suitable for this application. So that means it's an IMU that we see a lot for UAV and loitering ammunition application. For some subsea vehicles that have a hybrid mode, sometimes in the surface, sometimes underwater. And we also see it for navigation of ammunitions, for short-range ammunitions. The IMU is that the Pulse-40 is really performing well. And then finally, moving on to the Pulse-80. The Pulse-80, it's a fair bit bigger than the Pulse-40, but the performance is increasing also substantially. We're going down to 0.1 degree per hour in-run bias instability, making it really, really the high end of the tactical grade IMU, almost entering the navigation grade. Despite this very high performance, it remains very compact with a 5 by 5 by 4 centimeters, especially in its OEM form factor. It has a very good turn-on bias and a stellar in-run bias instability, making it very, very good for stabilization and control application for larger systems. So systems that are, especially when you need higher accuracy or you're pointing towards something that is further away. So EO system, RCWS, large antenna tracking, the Pulse-80 is really comfortable for these applications. It's also a very, very solid IMU to use for navigation application. From the moment you are able to estimate the initial bias and scale factor with GNSS availability at the start of the mission, that means that it's a very good IMU to consider for UAV, for example, for ISR application, or any application with long dead reckoning. Even some larger loitering ammunition are using the Pulse-80 as their navigation. It's also usable for ammunition, for some ammunitions. The more limited range than the Pulse-40 can be a factor, but the very good in-run performance and turn-on performance make it very at ease, and its performance level make it capable to be integrated in larger ammunitions and even going up to deep strike. No, I hope we've convinced you to try one of our IMUs. I just want to give a few words about what you'll get when you buy one of our IMUs the first time. And don't worry, we have a lot of accessories available for you to receive with your first purchase, so that you can easily try the first IMU you buy. So we provide you with dev boards, open wire interfaces, interface boards, everything that you need to be able to quickly evaluate the IMU, and with a unified solution to evaluate over RS422, so that if you want to evaluate multiple of our IMUs, you don't need to do a heavy redevelopment. On top of that, of course, we offer USB connectivity, so through a wire or a development kit that will let you configure the IMU and maybe even do a first acquisition on a desk before you go for a real test. On top of all the hardware accessories, we also provide an extensive documentation. So I've mentioned before the software documentation, but on top we have an even more extensive hardware documentation on our SBG support center that provides you the full hardware interfaces, electrical interfaces, software interfaces, integration guides, 3D models. Everything is available there. Everything you need to get started is available there. But if you still can't find what you need, or if you have any question, feel free to contact us. And on this, I'll hand it over to Noémie to wrap up the webinar.
Thank you very much, Johan, and thank you very much, Aymeric, for your very insightful presentation today. And a big thank you to our audience for joining us today for this webinar. Please note, you will receive a recording of this session in the coming hours. You will now find on the screen the contact details of all our different teams all over the world. So please don't hesitate to contact them if you have any question. So thank you again very much for your attendance today, and we hope to see you soon for another SBG Systems webinar. We wish you a very nice day. Bye-bye.